For today, we're going to discuss and tackle subgroups and lattice diagram of my geometric model, which is Marcos spiderweb, based on the group table we have constructed in the previous video. So this is our group table that we discussed and constructed in the previous video. So let us set our numbers and letters we have used in our geometric model, which are MARCOSQT 1, 2, 3, 4, 5, 6, as letter G, as the set. So here, we will verify the types of subgroup of G, which are improper subgroup, trivial subgroup, and proper subgroup. So in proper subgroup, we have the group itself. So in trivial subgroup, there is one element, which is our identity element. For our subgroup, this is our subgroup. Today, our motives here is to verify if this subset is uh, is a subgroup of our set, our set, which is the set of G. And based on our previous discussion, our group table is forms a group structure. So G is a group table. Our set G is a group table. So for our proper subgroup, we must verify if it is close, associative, has an identity element, has an inverse element for all, to conclude that this subgroup or this subset of G or this improper subgroup is a group also. So based on our table here, it is close because we have verified it in our previous discussion. It is also associative. It is also has a identity element, which is M. It is also has an inverse element for R. So this is a group indeed. So this is a group. So group G is equal to the set of MARCOS QT 1, 2, 3, 4, 5, 6, 7 under the binary operation. So for our G1, which is equal to M, our trivial subgroup. So it is close because the only output is letter M, which is close in our set of G1, which is equal to M. So it is close. It is also associative because when we flip it 180 degrees, the output itself is uh, remain letter M. So it is also has a identity, which is itself, and it also has a inverse element, which is also itself. So this trivial subgroup is a group. So G1 is a group which has a element M under the binary operation. So let's move on in our proper subgroup. So let's say G2 is equal to M and 1. So this is our table here. Now let's have verify if it is group. So it is close because as what you can see, our outputs are close or are within the set of G2. So When we flip it, or when we rotate it 180 degrees, our result is also the same. So M1, 1M, it is also the same as M1, 1M. So it is associative. So next one, it has a identity element which is letter M. So it is also has inverse for all. So the inverse of M is itself, and the inverse of 1 is also itself. So it is also a group. So G2, G sub 2 is group with the element M1 under the binary operation. Next one, G3, with an element with the set M and 5. So this is our table. Based on our table here, it is close. So when we flip our table, it is also associative. It also has an identity element, which is M. And for our inverse element, the inverse of M is M. And also the inverse of 5 is itself, which is 5. So it is also a group. For our G sub 4, containing an element M and 3. So this is our table here. It is closed because all the outputs are within the set G sub 4. So when we rotate the table 180 degrees, it is associative. And it has an identity element, which is also M, and it has also inverse element for all, which M, the inverse of M is M, and the inverse of 3 is itself. So it has an inverse for all. So G sub 4 is also a group. 1 G sub 5, it is closed because all the outputs are close or are within the set of G5. It is also associative because when we rotate 180 degrees, the resulting elements is also the same. It also has a identity element, which is M. So it also has inverse element for all, which is M. The inverse of M is M, and the inverse of 7 is itself. So it has an inverse element for all. So G5 is also a group. So G6, let's look if it is a group. So it is close. And when we rotate, it is also associative. It has also an inverse element and in the identity element, it is also has an inverse element, which is the inverse of itself, and the inverse of all itself. So this sub-6 is also a group. So let's move on and G7. So G7 containing element which are M and 2. So this is our group. So this is our table here. So it is closed because all the outputs are closed in the set. So it's also associative by rotating 180 degrees. The resulting element is also the same in the first table. So it also has an identity element, which is M, and it has also inverse element for all which M. The inverse of M is M, the inverse of 2 is itself. So G7 is so let's move on in our G sub 8. G sub 8 is also closed because it has a because the out or the resulting elements is closed in the set. It is also associative by rotating 180 degrees. It also has an identity element and also has an inverse element for all. So G sub 8 is also a group. So next one, G sub 9. So let's verify if this set is closed under the binary operation. So it is closed because all the resulting elements or the outputs is closed in our set, which is G sub 9. So if we rotate 90 degrees, the resulting elements is also the same in the first table. So it is It has also an identity element, which is M. It has also also has an inverse element for all, which ends the inverse of M is M, and the inverse of 4 is. So this G sub 9 is also 8. So G sub 10, we have the element M and 8. So this is our table. So look, if it's closed. So based on our table here, it is closed because all the resulting elements is closed in our set, which is G sub 10. It is also associative because when we rotate 180 degrees, the table, it is the same as the first table, which is which is defines that the table is associative. It also has a identity element, which is M. It is also has an inverse element, which the inverse of M is again M, and the inverse of 8 is itself. So G sub 10 is also a group. So next one, G sub 11, which is equal to the set of M, O, 1, and 5. So that's determined if this close. So based on our table here, it is closed because all the resulting elements or the outputs are closed in our set, just G sub 11. It is also associative because when we rotate it, it's also the same. So it also has a identity element, which is M, and it does also inverse. It has a inverse element for I. So this G sub 11 is also a group. So G sub 12, let's look if it is closed. So it is closed because all the outputs are within our set, which is G sub 12. And when we rotate it 180 degrees, it's also the same in the first table. So this is positive. It has also as a identity element, has an identity element which is M, and it has also has an inverse element for all, which is M. The inverse of M is M. The inverse of O is O. The inverse of 3 is self, and also the inverse of 7 is itself. So check for inverse element. So this G sub 12 is also a group. So next one, G sub 13. G sub 13 has a element which are MROQ. So this is our table here. Determine if it is closed. So it is closed because all the outputs are closed in our set. So when we rotate the table in 180 degrees, this is the output. So here it is not equal to the resulting elements in the table. But when we rearrange the column 1 to and the column 3, we have MROQ. The column is now correct, but our rows are not. So when we alternate row 2 to row 4, it is now equal to the first table. So it is associative. So it also has an identity element, which is M. It also has an inverse element for all. So G sub 13 is also a group. So next one, G sub 14. We have the element M026. By looking the table, it is closed because all the outputs are closed or within